Hello students. So we'll continue our class metals and non-metals. Last class we have seen about the properties of metals and properties of non-metals, and today we'll discuss those properties only but with some difference. Definitely question will be asked on this chapter. Write the differences between metals and non-metals. So here I have listed some differences. So we'll see those differences and according to that, we'll explain those. So first difference is generally metals are hard. So usually what happens is metals are generally hard, but Na and K are exception. See, generally metal hard. Usually the metals we see. For example, if you see the metal iron, if you see the metal copper, so these all are found to be hard. If you touch them, you can feel the hardness. But when it comes to non-metals, generally they are not hard. Okay, generally they are not hard. If you take a paper, plastic, okay, air, those are not hard. Okay, those are not having any hard nature. But here Na and K are exception. Na means sodium, K means potassium. These two are exception, means they are not hard. Sodium is not hard, potassium is also not hard. These two are less hard, these two are exception. Okay, but in that case diamond is exception. Diamond is a non-metal. You should remember this. Diamond is an allotrope of carbon. It is a form of carbon, allotrope of carbon. That means it is non-metal. Don't think diamond is a metal. Only gold, silver, platinum, these kind of materials are metals. Okay, so diamond is exception. So but diamond is hard. Generally non-metals are not hard, but diamond is an exception because diamond is, in reality, it is hard. Okay, second one, generally these are lustrous. These in the sense metals. Metals are generally lustrous. Lustrous means I have already told you, those which are having shiny nature. Okay, if they are cut or if they are in the normal also, if they have a shiny surface, we can call them lustrous. Means that is shiny surface property is called as lustre and they are called as lustrous. Generally these are lustrous, which metals are lustrous. But when it comes to non-metal, generally these are non-lustrous, but iodine and graphite are exception. See, iodine and graphite are exception. Graphite is also allotrope of carbon. Okay, and these are non-lustrous, but you can see graphite is present in your pencil. You can see that pencil is shining. Pencil has a little shine nature. If you observe that, you can get it. The tip of pencil, if you observe properly by side way, you can see that there is a shiny nature for that. So that both iodine and graphite, iodine means the salt we are using, you can see there is a kind of shiny nature. So both iodine and graphite are exception, means actually non-metals are non-lustrous, but these two being non-metal, they have a shiny nature. That means they are lustrous. So these two are exception. Exception means these don't follow the general rule. Okay, that we call them as exception. So we understood these two. Which one? The metals are usually hard with some exception. Non-metals are usually not hard, but diamond is an exception. Generally these are lustrous. Generally non-metals are non-lustrous, whereas iodine and graphite are some exception. Third one, generally having high density. They have high density. See, this is third one. Generally they are having high density. Generally having high density, but sodium and potassium, Na is sodium, potassium is K. Again they are exception. Sodium and potassium are again exception. The density means they should have large mass and less value. Density equal to mass by value. Rho, it is represented mass by value. So what is the SI unit of density? So mass is equal to kg, value is expressed in meter cube. This is mass by value. Density equal to mass by value. Mass is expressed in kg, V is in meter cube. So kg per meter cube is the SI unit of density. It might be asked for 1 mark. Remember this. It will come in physics, still you remember. Okay. Generally having high density. Metals are generally having high density. We have already discussed in the last class. Metals are generally having the high density. But sodium and potassium are exception. Sodium and potassium are exception. They are having the density almost 1 or less than 1. So their density is very less. Okay. But when it comes to non-metals, generally they have low density, but diamond is an exception again. Maximum times diamond is an exception. Generally they are having low density, but diamond is having high density. If you see the diamond, it is very strong. Okay, there is no pores in the diamond, it is completely packed. So when it is completely packed, that means its mass is more, its value is less. That means it is high density. So if you are not properly understand density, I will tell you. If you take a sponge and if you take a stone, the same size, stone is also there, sponge is also there. But stone is having, for the same size, it is having highest mass because it is completely packed, compacted, compressed or compacted it is. But in the sponge, what happens? There are a lot of pores. It is not compacted. Okay, it is having lot of pores. So that is why the density of this one is less. If you take ice also if you take, even though it is strong, it is not compacted. The same size of ice and same size of stone. Stone is more compacted compared to ice. Ice have lots of pore. It is porous. Okay, that means it is not having that much of weight. Okay, so here the density of stone is more compared to ice. If you take very easy example, if I say, if you take one ball, which we can say one cricket tennis ball, if you take, and if you take the same shot put, whatever we call, for the shot put we call that material. If you take the same size ball and material, of course the shot put material which you are taking is having more density because of it is having highest mass. I hope you are getting what is density. So now we will move to the, generally they have low density, diamond is an exception. Fourth one, generally malleable. Malleable means already we have understood. Okay, the last class we have seen malleability. Okay, they can be beaten into thin sheets. Metals can be beaten into thin sheets. Malleability is the property of the metals by which they can be beaten into thin sheets is called malleability. So generally these are malleable. Metals are generally malleable, but here also some exceptions are there. We call them as arsenic and zinc. We can call them as exceptions. Arsenic and zinc. And in your exam, if you don't write exception, it is acceptable. Even though you don't write exception, it's okay, but write the differences properly. Okay. Generally, these are non-malleable. Which are non-malleable? Non-metals are generally non-malleable. Means they cannot be beaten into thin sheets. Fifth point, generally ductile. Ductile means ductility is the property of the metals by which they can be drawn into wires. So metals can be drawn into wires. For example, if you take copper, aluminium, they can be easily drawn into wires. But what happens with non-metals? They cannot be easily drawn into wires. So it's generally non-ductile. Non-metals are non-ductile. If you take carbon, you cannot make wire by carbon. Okay, these generally non-ductile, non-metals are. Next one, generally sonorous. Generally sonorous. Sonorous means what? The property of metal by which they produce the ringing like sounds. That is sonorous. Even though you beat any metal, you feel sonorous kind of sounds there. But when it comes to non-metals, you will not feel such kind of anything there. That means if you take a plastic scale and metal scale, if you beat plastic scale, you will not feel any sound. But if you beat metal scale, you will feel some sound there. Okay. So it produces sonorous, that is ringing sounds. So that is generally they are sonorous, non-metals are non-sonorous. When it comes to conductivity, Metals are good conductors of heat and electricity. Generally good conductors of heat and electricity. Okay, heat and electricity. But these are poor conductors. Poor conductors of heat and electricity except graphite. Graphite is an exception. Graphite in the sense the material which is present in your pencils. It is exception. It conducts electric current. Graphite conducts electric current. Okay, you should remember that graphite conducts electric current, and generally these are good conductors of heat and electricity, whereas those are poor conductors of heat and electricity. Non-metals are poor conductors of heat and electricity. So these are the differences of metals and non-metals. Okay, please go through once. Generally these are hard, generally those are not hard. Okay, generally these are lustrous, generally those are non-lustrous, but some exceptions are there. Iodine and graphite are exceptions. Generally their metals are having high density, but non-metals are having low density. Okay, but here some exceptions, sodium and potassium, they are having the density only up to 1. Generally, these are malleable. Metals can be beaten into thin sheets. Okay, we can see copper sheets, iron sheets. So generally, these are malleable, whereas arsenic and zinc are exceptions. Generally, those are non-malleable. Means you cannot beat a non-metal into thin sheets. Generally, these are ductile. They can be drawn into wires for the purpose of flow of electricity. But these are not non-ductile. You cannot, we cannot use non-metal for the flow of for making the wire for flow of electricity, because they do not allow the electric current to pass through them, because they are insulators. They are poor conductors of heat and electricity. Generally, these are sonorous. So when it is beaten, metals produces ringing like sounds that we call as sonorous property. So maximum generally metals are sonorous, whereas non-metals are non-sonorous. Even though you beat those materials, you cannot get the sound like ringing like sound. Generally good conductors of heat and electricity, but they are the poor conductors of heat and electricity. In other words, you can say insulators of heat and electricity. So one exception, that is graphite. Graphite conducts electricity. So still we can see another one or two difference in this only. We have already seen 7 difference. In exam, if you write 4 to 5 difference, it is okay for 2 mark, and 6 to 7 difference, if you write for 3 mark, that is okay. And maybe it will be asked maximum for 2 or 3 marks. If it is asked for 3 mark, write 6 difference. For 2 mark, you write 4 difference. Okay. Now metals and non-metals. Non-metals go from this side. Okay, we can say that the tensile strength we can still define. Tensile strength of metal is more. Tensile strength of metals is more. Tensile strength is less. Tensile strength is less. These are the things already we have seen. This property also we have seen. Tensile strength means the capacity or the strength to hold the pressure. So even though lot of pressure is applied, it should not break. Okay. If it is not breaking, means it is having the capacity to maintain that pressure. Okay. Sustain that pressure. So when the pressure is sustained, we call it is more tensile. So metals are having the tensile strength more. So even though there is more pressure is applied on metals, they can conduct, what I can say, they can have the capacity to sustain it for maximum time. But when it comes to non-metal, they don't have that much of sustainability. They will break it. They got break. So non-metals are having less tensile strength, whereas metals are having more tensile strength. Okay. So ninth one is not there. So these are the 8 points you have to remember. These are the 8 points. Out of this, you can write 4 for 2 mark, and You can write 6 for 3 marks. Examples if you take 9 1 or examples if you take, what are the examples of metals you can write? Sodium, that is Na, potassium K, silver Ag, and gold Au. You can write copper and iron. Enough. There are 6 these are. You can write it in names also. Names also you can write, or you can write sodium. K means potassium. Potassium. Ag is silver. Au is gold. Cu is copper. Fe is iron. So these are the non-metals. So these are the metals. Non-metals examples what we can have? We can have paper, wood, wood. Then what we can have? Air, balloon. Okay. Next, blackboard, chalk, etc. So we can have them as non-metals. So graphite, we can say, if you are writing properly, we can say graphite. Graphite is a non-metal. We can say like that. So these are the examples of metals and examples for non-metals. So I hope everything is clear with metals and non-metals difference. So now we move to what is element and what is atom. After that we can have some formulas of metal. Okay. So first we learn definition of atom. What is atom? Atom is the smallest part of an element. This is the smallest part of an element. Part of an element which what it does? Which takes part in chemical reaction. Which takes part in chemical reaction without losing its identity. Atom is the smallest part of an element which takes part in chemical reaction without losing its identity. Without losing its identity. Its identity. So, what is atom? Atom is the smallest part of an element which takes part in chemical reaction without losing its identity is called as atom. For example, if I take, for your convenience, for example, if I take this chalk piece, I can break this chalk piece to the maximum times such that I cannot break it again. We have to come to such situation that it should not be broken again. Then we say that it is an atom which cannot be further divisible. So that part we call it as atom. The smallest part of this chalk is the atom of the chalk. Smallest part of iron is the atom of iron. Smallest part of copper is the atom of copper. This is the smallest part of an element which takes part in chemical reaction. It takes part in chemical reaction, but it does not lose its identity. It doesn't lose its identity. Without losing its identity, it's called atom. So, as I have told you, atom of Na, atom of copper, atom of iron, these are the examples. Okay, these cannot be divisible. Atoms are indivisible, but you can see electrons, protons are present in that. But these are usually these are indivisible. Again, these are the very smallest part. So atoms are what? Very small. So after this atom, we can see element. Definition of element. Element is what we can say. Element is a single thing. That means it is made up of atoms. Element is the material or matter which cannot be divided, this cannot be divided, which cannot be divided, which cannot be divided into two or more things or more elements or more atoms. It cannot be divided into two or more substances. It cannot be divided into two or more substances without any without any chemical force or external aid or electrolysis or external aid or electrolysis. Okay, element is the material which cannot be divided into two or more substance without any chemical force or external aid or electrolysis. Without electrolysis, element cannot be divided into two or more substances. Suppose if I take this is element of iron, even though divide it, it is element of iron only. You cannot make into iron and copper. Okay, you cannot make into sodium and potassium. If I take sodium, it is sodium only. Even though you divide it, it is still sodium. Still sodium atoms are there, but it cannot be divided into sodium and potassium. Other materials will not come. Element is the material which cannot be divided into two or more substances without any chemical force or external or electrolysis. Sometimes if you apply electrolysis, there is a chance, okay, that they can be divided, but very less chances are there that the elements can be divided. So I hope you understood what is atom and what is element. So you have to remember. So element examples we can write. What we can write for the examples of elements? We can write sodium is an element, right? Iron is an element. You can write the elements like this. So you have to remember these two definitions. So what is atom? Today in this class we have seen difference between metals and non-metals, definition of atom and definition of element. So you have to remember all these things. So metals, non-metals and malleability, ductility. This is very important question I am going to tell you. Define malleability and ductility, properties of metal, properties of non-metals. Okay. So you have to remember these things. Malleability and ductility. Differences between metals and non-metals. Okay. Then some exceptions. Which is the, even though non-metal, which is the best conductor? That is what? Graphite. And metals are usually in solid state, but which is an exception? Mercury. The mercury used in our laboratory. Or if you go to a doctor, thermometer is there. In that thermometer, mercury is present. That is clinical thermometer. In that also thermometer is present. In the labs also we have practical thermometer. In that also laboratory thermometer we can call that. In that also mercury is present. So you should remember these all things. Okay. So malleability and ductility. What is malleability and what is ductility? That is very much important question. If the property of metals by which they can be beaten into thin sheets is malleability. The property of metals by which they can be drawn into wires, that is ductility. Okay, you should remember all these things. Metals are good conductors of heat and electricity, whereas non-metals are poor conductors of heat and electricity. Exception is graphite. You should remember that. And diamond is not a metal. Diamond is an allotrope of carbon. It is a non-metal. You should remember that. Okay, these are the things with metals and non-metal, element, atom. Okay, properties of metal, properties of non-metals, malleability, ductility, sonorous, tensile strength. You should remember all these things. Okay, so these are the things. Metal, liquid present in metal. So liquid metal we call it as mercury, and there is one liquid non-metal that we call it as bromine. Bromine is, you should remember, bromine is a liquid non-metal. These questions might be asked for your 1 mark. Bromine is liquid non-metal and mercury is liquid metal. Mercury is liquid metal. In 1 mark, this might be asked. So, if they ask metals are non-metals are or non-lustrous, but some exceptions are. Which are there? Graphite and iodine. Graphite you can see with your pencil, it is having shiny nature even though it is non-metal. Some kinds of question might be asked like that. Remember that, and for 1 mark they might ask those kind of questions. Okay, we'll see about some metals and their symbols and chemical properties of metals in upcoming classes. Thank you.